I'm going to show you how to build a simple classifier in Python. If you're new to machine learning, you will find this interesting. If you're already familiar with machine learning or build models, you may not find this very useful because this is very basic actually. I'm going to take the simplest possible model to demonstrate how you can build a model quickly in a couple of minutes time. Right, a lot of things are actually available on the internet. That means you do not have to write your own classifier. You rather use the ones available already, and you can quickly build a model. Right now, there are many more things to learn. It's not just about calling a library and build a model quickly. There are many more things to give attention to. But without being overwhelmed by a lot of the jargons, you can easily build a model first and then start understanding the different theoretical aspect of it. That's also a way to go about learning machine learning. So hence I have taken this very simple example. I will be taking more complicated ones, obviously, right? You can start with a very basic, and here we have taken a random forest classifier from the the package Sklearn, which is very famous one, the scikit-learn. You can visit the scikit-learn website to understand more. There are a lot of information out there, so if you're new, actually you will be overwhelmed with so much of information, but I'll break it down for you. I'll take the simplest possible model to demonstrate as to how you can build a very simple model and what machine learning is all about. If you see an example, it will create more interest, and it will then be more interested to learn how it happens, the theory behind it, the different aspects that you need to take into account while building models. We'll go into the details maybe in other videos, but for this one, see here how we build such a simple model. Now, why it is called ensemble? Because it's a type of model where it combines multiple classifier into one. Okay. And why it does and all that stuff, we can talk about it in a separate video, but I'll tell you that when you combine more models, the performance is improved, performance is better. And random forest, what it does is that it is a classifier model which combines output from other classifiers and thereby improving the performance of individual classifier. So the final result is therefore more improved. And there are other types of ensemble models also, for example adaptive boosting, random forest, and gradient boosting, and so on and so forth. But we will not go into details of other models and what the models are. I've got a video on this channel on random forest. You can watch that also if you want to learn theory. Okay, so here we have imported random forest classifier. You can import adaptive boost and gradient boost also. Okay, and we'll use this classifier to build a very simple machine learning model. So it is a classification model. So what it means is that, so given some information, we would like to classify into groups, right? You can take a real world example also. For example, a fraud, a credit card fraud, yes or no. It could be about whether someone will win the lottery or not, yes or no. So it's a yes or no problem, right? Classifying into either yes group or no group. So so we first define the targets and the input variables, right? When you build a model, you start first by training your model, and for that you need inputs and output. You need historical data. You need data for the same event that has happened in the past, and you will use that information to predict the future, right? So using the past information, the historical information, you will train your model, right? And training of model is nothing but simply giving information that, look, here is the input, here is the output. You find the pattern, right? The model will find the pattern itself, and model will use the same pattern to predict for the future, and we'll see how it does. Okay, so here we have got x variables, which is the input. It has got information for five cases, right? And there are 4 columns. That means there are 4 features, 4 independent variable, 4 features. You could assume like, okay, you want to predict, for example, credit card fraud happening. It could be, okay, the type of credit card, the balance, the age of the customer, where it was transacted. So all this information could go as input to such a model. I've just taken random input, so it doesn't matter what the inputs are, but it just taken some inputs. Okay, so there are just 4 of them, 4 inputs. That means 4 features, 4 variables, and I've got 5 number of observations. Right? In real world, you will have many more, by the way. Right? You cannot build a model just with the 5 observations. Right? I've taken this example actually from Sklearn, and they have taken 2 observations. Right? If you're coming from statistics, econometrics background, that's actually outright wrong. Many people will actually even question whether you can build something like this. Right? You will have like 2-3 parameters, but just 2-3 observations. Right? That's actually wrong from that point of view, but from theoretical point of view. But you can actually build a model also, not a problem, but that model is not reliable. So in real world, you will have many more variables and many more observations. Right? Many people use this as a thumbnail, that as a thumb rule, that you need to have at least 30 observations to be able to build a model. You could, the more the better. Right? And then you have the target variables here. Okay, target is nothing but your class information, right? Which group a given observation belong to. And this is historical information, by the way. You will use this historical information to train your model. The model will be then familiarized with this information and will find a pattern between X and Y. So it's all about finding a relationship between X and Y, right? So that's all about machine learning actually. It's about finding a relationship between X and Y. X is the input or the list of inputs, and Y is the output, right? So, all right. So here you take the random forest classifier. Okay, you can take an instance for it and use that and use X and Y as inputs, right? We start with X, with the input, list of inputs. Here just pay attention. We have used the capital X because it has got like more than one input variables, right? Therefore it's capital X. I mean, nothing wrong with using small x also, right? But it's just about notations, right? And then you have the Y, which is the target here, right? So target could be 0 or 1, right? Usually we denote groups as 0 and 1, and you'll most classification problem will find 0 and 1, but it need not be 0 and 1. Actually, it could be also other classes, right? Class A and class B, right? And it could also have multi classes, right? Not just 2 options, but also more than 1 options, right? A, B, C, for example, 0, 1, 2, something like that. That could also be a problem, and it's called multi-class problem, right? We'll see that in some other videos. All right. And here you go, right? Just you have this classification. We just use classification.fit, provide the input and output. You were done actually, right? And just run this. I've already run this, so maybe I can run it again. So the model is run. That means you already have. You can actually store that somewhere also, but if you're doing in the same instance, you don't have to do it. You don't have to store it, but you can also store it in, let's say, some other variable, right? And then use that variable, right? Let's do that also, right? Let's store it in JET, something like that. Okay, so now the model estimates are stored in JET. If you're coming from stats or mathematics background or econometrics background, you may be wondering, once you have built the model, we need to see the estimates and all that. In machine learning, you may not be interested to just about understanding the model estimates. Oftentimes what you do is that you do a back and forth. That means you build a model, you check the result, you go back and change a few things, and so it's an iterative process. Unlike in statistical models where you do not care about predictions until and unless you are confident about the model estimates and signs and all those things, right? All these things can also be done here, right? It's just that the approach to model building is a bit different in machine learning, wherein it's an iterative process, right? where you validate your model in a separate data set and check the performance, and you return back to original model building, you rebuild the model again, check the performance in another data set, and you keep on doing that, you iterate that until you find the best fit line. So machine learning is all about predictions actually, although some people might dispute that, but whatever little I've seen, most people are interested only in prediction and achieving prediction accuracy, unlike in statistical model, wherein you are interested not just about prediction but also about relationship, about drawing inference about between input and output. All those things are of secondary import, in fact of no importance in machine learning, and hence the process of building model is somewhat different. And this is simplest possible way of building model. Like you define the input and output, you take a regression, import it, which is already there. By the way, we are not writing actually random forest classifier ourselves, it's already there, we can make use of it. And you could also use multiple models and see where the prediction is the best, right? That tool could also do. You can not just use random forest, and for a given problem you can use more than one classifier, whether it's AdaBoost or random forest and gradient boost and see actually which one is performing the best in a new data set, right? And you can then use the one that performs the best as the final model. So it's the process. So the what needs to be understood here is that it is the process of building model is somewhat different if you're coming from a statistical econometrics background, right? And then here we see we have built the model, we have trained our models. It's in Z, so let's use here Z instead. It should be Z.predict, right? All right. Okay, have you run it? Yes, now we have. So when you Z.predict, we have to provide new data. Actually, we are providing new data to predict whether it's yes or no, or 1 on 0. Okay, so here we go, it's 1. Okay, let me try something else. Let's see, something like this. Let's see what comes out. Oh, it comes out to be 0, right? So this is how to build a very simple model. As I said, it's somewhat different from other statistical model building process, because the reason why you build a machine learning model is slightly different, right? It is a lot more practical compared to theoretical statistical models, and these are models used in engineering problems compared to statistical models which are used mostly in social science or fundamental science. All right, so we will take a data set, actually a proper data set, real world data set, to understand how to build a model. We will build a model using proper data maybe next time, okay, in the next video.